Dr. Warren. Dr. Warren.
Yeah.
I know that a few of us had some issues with the WebAssign homework, just the content of it. So would you be able to go over some of that today?
Sure, Lindsay. I don't know how much time I can invest into it, but if you ask some questions, I'm sure I can hit some of it for you.
Okay, great. Thank you.
All right, guys, let's stand up and let's get the videos on so I can see your faces. Stretch, stretch, stretch. Oh. Oh. All right, let's sit back down. Number one. I guess as kids come in and join us in class here. Mason, you're upside down. Oh, there you are. Now you're okay. There we go. Perfect. Okay. We are not going to have a quest on Wednesday. We are not going to have our second quest on Wednesday. It's going to be on Friday. I just got assigned a big classroom for our Fridays. We will now be able to meet all together in a single classroom on Friday. So it makes it super simple. There you will be, I'll send it in an email, but I'll just explain. If you're a Z-Dayer, you will meet with me in class in our regular room on Monday. And you'll meet in our new room, which is Burris 31. It's the basement of Burris. It's a big classroom, stadium room. You'll meet there on Friday. It keeps it super simple. So Z-Day will meet Monday and Friday. A-Day will meet Wednesday and Friday. I am still on those Monday and Wednesdays. We're still going to be Zooming. For those of you who are an A-Dayer or a Z-Dayer. So if you're not in class, you can still attend the lecture live. And then we'll keep taping and putting those up too. So you have access, you have a lot of access. But our testing days will always be on Friday. Which keeps it super simple. Okay, so no quest on Wednesday, quest on Friday. Okay, Lindsay, you were talking about something related to the WebAssign. Maybe I can talk about that for a little bit. Could you give me a problem?
Yeah, I can go to the WebAssign right now and get a problem. It was just the ones that were asking for like m equals and y equals, and it would give you like a function. And it was just a little confusing. Like we didn't, like people in the group me didn't really know like how we should be going about doing it.
So why don't you throw it at me? Just if you can throw me the problem. I'm not sure which problem that is.
Yeah, I can pull it up. So there was one where it said find the slope of the tangent line to the graph of the function at the given point, and then it was f of x equals 3x minus 2x squared at -3, -27.
3x minus 2x squared, and what was the point?
At -3, -27.
Okay, and they want us to find the equation of the tangent line or the slope of the tangent line?
So the slope and the equation.
Okay, so if I'm looking at this, let's first of all make sure the book has it down. If you put a -3 in for x, you're gonna get -9 here, okay? And then -3 squared is +9. +9 times -2 is -18. Take away 9 more is -27. Okay, so we at least have a point on the function. Now when I say tangent line, ding, you write down what formula. Whenever you hear the word tangent line, ding, you write down what flashcard.
Y minus f of c equals f minus c, x minus c.
Perfect. Okay, the next thing you have to identify is you got to cast this play a little bit. Who's playing the role of C? Who's the C in this flashcard? The -3, the x coordinate of that point. The x coordinate of that point. So now in that flashcard, just kind of where it is right now, replace all those C's with -3s. So in that flashcard, replace all those C's with -3. Is everybody with me so far? Is everybody like on the same page? Okay, the next thing, let's try to get rid of this guy because that's not that hard. It's always going to be the y coordinate. It's always going to be the y coordinate of that point. So let's just go step down and put that in there. I've got a -27, so then I would have y plus 27. Y plus 27 equals f prime of -3 times x plus 3. Now comes the hard part of the problem. The slope of the tangent line is the what of the function. The slope of the tangent line is the what of the function? The derivative. So now I want to find f prime of 3. But we do not have any of our derivative tools locked and loaded yet. We have no way to take the derivative right now except by using the limit definition. We can only use the limit definition of derivative right now to find this f prime of -3. So let's go back and help. You guys can help me. By definition, what's the derivative of f prime of -3? And I'll help you. La 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 la. Dr. Warren, that was no help. La 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 la. How do we define the derivative in here?
The limit as x of
the limit as, help me out, the limit as
x of
x approaches -3.
The limit as x approaches -3. Who's the Gary Dreibelbis? Who's the Gary Dreibelbis? X plus 3 or x minus -3. I'll just put it in kind of like we'd see it in the definition. And then what goes up here, guys? What goes up here? What goes up there?
F of x minus f of c.
F of x, yeah, minus f of -3. And I don't know, maybe it was Mason was like already on top of it, or Zach was already saying, okay, who is the f of x here, guys? Who is it specifically in this specific problem? The function was, yeah, and what did f of -3 end up being? What value did f, I mean, we already put it in here. What value did f of -27? So then I'd be looking at the limit as x approaches -3. I've got my Gary Dreibelbis, which I'll put him in that form. He's the troublemaker. He's the one wanting to cause division by 0. Now put in my function, that was 3x squared minus 2x, 3x minus 2x squared, and then f of -3, this minus, that minus is that minus, that minus is that minus, and then I've got my f of -3, which is my minus 27. Now what's the problem with this limit, guys? What's the problem with this limit as it stands? What's the problem with the limit? The denominator wants to go to 0. It's trying to kill us by going to 0. The limit's going to exist. So what must be one of the factors in the numerator? What must be one of the factors in that numerator?
X plus 3.
X plus 3. So we know one of the factors is going to factor into x plus 3. We could just rearrange this a little bit. Negative 2x squared minus 3x plus 27, Okay, now you guys look at, you've got an x plus 3, but you want to create that. You've got an x plus 3, you need to come up with another binomial to create this. Let's look at this guy. I want a 27.
Why would that be plus 3x?
Oh, bless you. Thank you.
Thank you.
I should know, when everybody's eyes look confused, I'm wrong. I want a 27. What would I need here? What would I need in that location to grab that 27?
9.
A 9. Now, would it be a plus 9 or a minus 9? Would it be a plus 9 or a minus 9? Look at the result that we have there. Would it be a plus 9 or a minus 9? Plus. Now, I also need a negative 2x squared. So what would that leading term have to be? Negative 2x. Now, we shouldn't trust ourselves, especially if you're like Dr. Warren, okay, who makes all kinds of mistakes. Let's just make sure the middle terms work. And when I do that, I check my middle terms. I have a minus 6x plus 9x. Minus 6x plus 9x is, I know this is hard, minus 6x plus 9x is 3x. Is that not the middle term? So now we slash her. Is there any more division by 0 to worry about? Pull out your continuity and just plug it in. And what numerical value do you get? When you just plug it in, what numerical value do you get? You can do this. I know you can do this. When you plug it in, what numerical value do you get? 15. Now, where does that go? Where does that number go into the equation of our tangent line? Where does that value go in the equation of our tangent line? Yeah, it's right there. So what is the slope of the tangent line? What's the m? What's the slope of the tangent line? 15. And so when I put this in here, we're there. And then if they want y by itself, it's not hard. At that point, you kind of own it. Does that help, Lindsay? Does that help as far as?
Yeah, that helps a ton.
Okay, so the biggest thing is, whenever I say tangent line, you guys write down
Y minus f of c equals f prime of c times x plus c, or minus c.
yeah, so that's it. I mean, that starts you off. If you do that, you're probably going to get at least 3 points. If you only write this down and it's a 10-point problem, you're probably getting 3 points because you have the equation in the game. Okay, stand up again. You already need this. Stand up. It's Friday. Stretch. Did I tell you about the time my brother Doug, when the police showed up? I told you about the time he pried all the stuff off of cars, right? I told you about that. But I tell you about the time the state patrolman showed up at the house and was brought my brother Sam home, because my brother Doug and his good friend Danny Acuna, who were like probably 13 years old, and my brother Sam was probably like 9, they went over and spent the night at Danny Acuna's house, and the state troopers found my brother Sam and Danny's younger brother Martin duct taped to a tree in only their underwear in February. Because they were playing a game that Doug came up that was called Japanese concentration camp. They were playing a game that was called Japanese concentration camp. And so they marched them barefoot through the snow and then duct taped them to a tree, telling them that they would get to be the commandant next time. Okay? So when I see the Gary Dragobis, I also often think of my brother Doug. Okay, how many people recognize this is kind of a challenging, painful way to take a derivative? How many are like, Dr. Warren, man, this took a lot of work. Is there an easier way? Ask that question.
Is it easier way?
Yes, there is. Derivative flashcards. And let me remind you of 3 of our derivative flashcards. We now know, because we use the limit definition of derivative, we now know that the derivative of x is always
0.
close. Okay, Laney's got it up. Your number 1. The derivative of x is always 1. Now you're ready. The derivative of any constant, 7, 15, whatever, the derivative of any constant is 0. Now comes the hard one that we were talking about on Friday, product rule. If you have any function times any other function, you have 2 differentiable functions, 2 functions you can take the derivative of, and you're multiplying them together, what's the derivative of that function? Don't you look at your notes. You write down anything that you've got in your gray matter. Write down the best thing you've got in your gray matter. Okay, let's see what you've got. Let's see, hold it up. Let me see what you got. Everybody should be holding something up. Let me see what you got. Hold it up, hold it up. Some of you aren't holding up anything. Hold it up, hold it up, hold it up. This is a hold up. This is a hold up. This is a hold up. Alexander, what do you got there? Alexander, what do you got? Steve, all I see is a beer bottle. And I like that, Steve, yes. Henry, what do you got for me, man? Henry, what do you got? Yeah, nice, Henry, nice. Okay, guys, okay. Here we go, here we go. The derivative of f times g is equal to, you guys help me out. The derivative of f times g is equal to the
F prime of
g. The derivative of f times g of x
Plus f of x times prime of x.
times g prime of x. It's not what we hoped. We hoped it would just be the derivative of f times the derivative of g, but there's a plus sign. There's a plus sign. That plus sign came from the foiling. If you remember kind of what we were doing last time, it came from that foiling that we were doing. It's f prime times g plus f times g prime. Anytime you have a function times another function, this is the way you take the derivative of it. Now we're going to use this rule to build another rule. We're going to use this rule to build another rule. We know the derivative of x, and you didn't have this down. We now know the derivative of x is, one. So now, watch this move. Yo! Yo! Okay, that's not the move I really was thinking about. I was thinking more about this move. Suppose I wanted to take the derivative of x squared. Suppose I wanted to take the derivative of x squared. I could use it in the definition of derivative. I could do that. We've done that. But explain x squared to your little sister. What the hell does x squared mean? X times x. It's the function x times the function x. Could I not use product rule? Could I not use product rule? So let's use product rule. It'd be the derivative of the first guy, that guy, times that guy, they happen to be the same, plus this guy, times the derivative of that guy. Now, what's the derivative of this guy? What's the derivative of this guy?
1.
1. What's the derivative of this guy?
1.
1. 1 times x plus 1 times x, 1 times x plus 1 times x. How many x's you got? How many x's you got? How many x's you got? 2. And so the derivative of x squared is, using product rule, the derivative of x squared is
2x.
2x. So let's just write this down over here. You guys write down in a list. We now know the derivative of x squared is 2x. We now know the derivative of x squared is 2x. How many people followed that? How many people followed that? How many people are with me with what we had there? Okay, now let's take the derivative of, no, let's not do that, Dr. Warren. Let's take the derivative of x cubed. If you use the limit definition for this, it would hurt. It would hurt really bad because you really struggle to factor cubes. Squares, parabolas, you're pretty good. Quadratics, you're pretty good. Cubics, you're like, no, I'll lose the points. I'll just take the loss in points. I'm not going to try to factor a cubic. Now, I've got to ask, is x squared times x the same thing as x cubed? Is x squared times x the same thing as x cubed? Is x squared times x the same thing as x cubed? And this takes us back to high school. Takes us back to high school. And this is what you must teach your little brothers and sisters. If you say 2 to the 7th, explain that to your little sister or brother. 2 to the 7th. What does that mean? What does that mean?
2 7 times.
2 7 times. So it's this means 2 times 2 times 2 times 2 times 2. I should have not picked 7. Times 2. Now let's imagine that I've got 2 to the 7th times 2 to the 3rd. Well, this means this 2 times 2 times 2 times 2 times 2 times 2 times 2. But 2 to the 3rd means 2 to the 3rd means 2 times 2 times 2. I know this is a lot of 2's. So this means 2 times 2 times 2 times 2 times 2 times 2 times 2. 7 of these. This one means, help me out, this one means, this one means, this one means.
2 times 2 times 2 times 2.
How many 2's do we got? How many 2's do we got?
10.
10. So this is the same thing as 2 to the
10.
10. Your brothers and sisters can hang on that. They'll get that. They'll understand that. What if I had 2 to the 7th? Now, not times, but divided by 2 to the 3rd. Well, this means this divided by that. Get out your sword, get out your sword, get out your sword. And you go slash, 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 and you're left with how many 2's? You're left with how many 2's?
4.
2 to the 4th. So 2 to the 3rd, 2 to the 7th over 2 to the 3rd is 2 to the 4th, which is the same thing as 2 to the 7 minus 3. If you just do it with this, they'll start understanding rules of exponents. Now I come back here. Is x to the 1 times x to the 2 x to the 3? Is x squared times x cubed?
Yes.
Yes. Let's use product rule. No, Dr. Warren, let's not use product rule. Let's use product rule. It'd be the derivative of x squared, but what did we find that to be? What did we find that to be?
2x.
2x. I'm going to do this in 2 steps. You don't need to. I'm just helping some of the people that may struggle a little bit. This would be the derivative of x squared times x using product rule. What's in the middle of product rule? What's in the middle of product rule? A big old what?
Plus.
Plus x squared times the derivative of x. Well, what's the derivative of x squared? What's the derivative of x squared?
2x.
2x times x plus x squared. What's the derivative of x? What's the derivative of x?
1.
1. Now look at this, guys. You've got 2x times x plus x squared. But x times x is the same thing as x times x is the same thing as
X squared.
x squared. So this is 2x squared plus x squared. How many x squared you got? How many x squared you got? How many x squared you got?
3.
3. So the derivative of x cubed is 3x squared. The derivative of x cubed is 3x squared. Let's write that down over here. We're going to do one more. We're going to do one more, and then we're going to write down the general rule. We're going to do one more. How many people are following? How many people are with me so far? Okay, slap your face. Slap your face. Japanese concentration camp. Japanese concentration camp. Slap your face. No Japanese concentration camp. Okay, sorry. Remember, I was born in 1961. Okay. Okay, none slap your hand. None slap your hand. No. Do fish mouth. Anything to wake up. Come on, Zach, you can do better than that, man. Zach, I'm not teaching until I see fish. There we go. Okay, good. Here we go. One more. Are you ready? Say, I'm ready, Dr. Warren. I'm ready. I'm with you.
I'm ready, Dr. Warren, I'm with you.
Say that was less than enthusiastic. Okay. Don't you look at the board. Don't you look at your notes. I am talking to the board. What's the derivative of x squared? Woo! Okay, that was one person. What's the derivative of x cubed?
3x squared.
3x squared. We're now going to look at the derivative of x to the fourth. We're now going to look at the derivative of x to the fourth. You can't factor a cube. You're going to struggle even more to factor a fourth. Watch, let's do the same thing we were doing before. This is the same thing as a product of x cubed times x. This is the same thing as the product of x cubed times x, because x cubed times x is x to the fourth. Now you guys are going to do the product rule for me. You guys, you've watched me work, now you work. You take product rule and apply it to this function f, x cubed, whose derivative we know now, and this function x, just like what we were doing. You pick up your pencils and you do some work. Now simplify, now simplify, now simplify what you have. Now simplify what you have. Okay, now you're going to breakout groups. Now you're going to breakout groups and you're showing each other what you have. You're going to be with me live, some of you, on Monday. How many people got 4x cubed? How many people got 4x cubed? How many people got 4x cubed? So let's just check, go through again. Product rule, derivative of the first times the second, plus the big thing in the middle, plus the first times the derivative of the second. You guys now know your number 1, the derivative of x is 1. X cubed, you probably forgot. We'll go over here and look at the board. You find it's 3x squared. Now this is where it gets a little hard. X squared times x is x cubed. We have another x cubed. If you have 3 apples and you add another apple, how many apples do you have? If you have 3 apples and you add another apple, how many apples do you have? 4 apples. Okay, so we would then have 4 apples, which is 4x cubed. So we just showed, using product rule, the derivative of x to the 4th is 4x cubed. We showed the derivative of x squared was 2x. The derivative of x cubed is 3x squared. We just showed the derivative of x to the 4th is 4x cubed. What do you think? I mean, we're not going to do it. But just doing a little pattern recognition. If we went and did it all over again for x to the 5th, what do you think we could show the derivative of x to the 5th is? 5x to the 4th. Notice it's almost like we took the 4, dropped it down, and subtracted 1. The 3, drop it down, subtract 1. The 2, drop it down, make it a coefficient, and subtract 1. If we did x to the 5th, that would free up x to the 6th. And what would the derivative of x to the 6th be, guys? What would the derivative of x to the 6th be? What would the derivative of x?
6x to the 5th.
6x to the 5th. And we could keep doing this for all of the natural numbers. We could keep doing this for all of the natural numbers. By the power of product rule. By the power of product rule. So, like, what about the derivative of x to the 100th? What about the derivative? Imagine using the limit definition. You're like, no, that's too scary. But now, using product rule, we could show the derivative of x to the 100th is what? Write it down. Write it down. Write it down. Don't say it out. Write it down. What do you got? What do you got? What's the derivative of x to the 100th? Now go to grid view. 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 So you can see all your classmates. Go to grid view. You're going to see a bunch of them. You're seeing everybody in this grid on Fridays. You're seeing everybody in this grid. Zach, you look a little dark there, right now. Christian, not seeing you either. You're a little bit in this. Trey, not seeing you. Parker, okay. Everybody else, hold up what you have. Hold up what you have. What do you have? What's the derivative of x to the 100th? What's the derivative of x to the 100th? What's the derivative of x to the 100th? Yeah. 100 x to the 99. 100 x to the 99. 100x to the 99. So from now on in this class, when you have to take the derivative of x raised to a power, you can use this. You can use this unless I say make a limit proof. Take the derivative using a limit proof on a quest. Other than that, you can use this new friend we're going to call power rule. What did I just say? What were the words that just came out of my mouth? Because you're all zoning. Well, what were the words that just came? Power rule.
Power rule.
Sorry, Alexandra, we went right over top of you. Okay, so do this. Power rule. Power rule. Okay, so now I'm going to write down our power rule flashcard. Now I'm going to write down our power rule flashcard. Our power rule flashcard looks like this. I'm going to write it big. If you have the derivative of x to the k, x raised to any power, we can show that's equal to, and you guys can kind of tell me what did you do with the 100? What did you do with the 100? What did you do with the 100? You dropped it down as a coefficient, big K, x to the, what do you think it's going to be, guys? What do you think it's going to be? X to the K minus 1. And this is our power rule. This is our power rule. Okay, look at the clock. Look at something that tells time. Look at what time is it? What time is it? Tell Dr. Warren.
12:38.
12:38. What time is class end? What time is class end?
12:50.
12:50. All right, write this down. Write down K times G of X. Write down K times G of X. You're not just going to just be scribes. Write down K times G of X. Now put a big derivative around it. I'll help you out with that. We're trying to figure out what happens when we have a constant times a function and we want to take the derivative of it. Because this could be a nice flashcard too. This could be a nice flashcard too. What if you've got a constant times a function? Is there a flashcard associated with that? Let's use product rule. Let's use product rule. This is the first function, this is f, and this is g. So we're going to use product rule. It would be the derivative of the constant times g of x. What's in the middle of product rule? What's in the middle of product rule? Plus, so put a big old plus there. Plus the first function, k, times the derivative of the second function. Now go back and look at flashcard number 2. Go back and look at flashcard number 2. What's the derivative of k? What's the derivative of k? 0. But 0 times anything is, 0 times any real number is 0. So this goes away. And we end up with this really nice flashcard that says the derivative of k times g of x, the derivative of k times g of x is just k times g prime of x. You're like, Dr. Warren, those are the same damn things. No, they're not. No, they're not. Here are the derivatives on the here are the constants on the inside. Here are the constants on the outside. Here are the constants on the inside. And here are the constants on the outside. So let's make this a flashcard. I'm just going to write it. I'm going to write it right here. I'm going to write it in this space right here. So this is the flashcard. K times g of x. The derivative of k times g of x is equal to k times g prime of x. So write that down. Okay, so now I've got to ask some questions. When we use the limit definition, we use the limit definition to show the derivative of x was 1. Did you guys follow that? Do you have that in your notes? Did you follow that for the most part? When we showed the derivative of a constant was 0, again, it ended up being just k minus k. Product rule, nah, you didn't follow it all. You just factored, you threw some stuff in, you were like, I kind of understand. How many people kind of understood our development of the derivative of x to the k? I mean, how many people understood? We use product rule over and over again to get the derivative of x to any natural number. You just drop it down and subtract 1. How many people understand if we combine this rule, that rule there, and this rule here, if we combine the derivative of a constant and product rule, we get our constant multiplier rule. That we just pull a constant right outside of the derivative. A constant multiplier, we can just pull it right outside of our derivative. You're like, Dr. Warren, when would I ever use this? Well, let me show you. Let me show you. Imagine that you had to take the derivative of something like this. Suppose you were looking at like 7x to the 4th. You were looking at 7x to the 4th, and you were asked to take the derivative of that. You're asked to take the derivative of 7x to the 4th. How many people are pretty comfortable they can take the derivative of x to the 4th? How many people like now are like, Dr. Warren, I kind of own that. I could probably take the derivative of x to the 4th. And the 7 isn't so bad. Well, this guy, you won't listen at all now, so it doesn't matter what I say. You see what time it is? 43. You have 7 more painful minutes. It's going to be even more painful because I'm going Mickey Mouse. Well, boys and girls, so here we are now. Now we've got this function 7 times x to the 4th. Now over here in my flashcard, who's the 7, boys and girls? Who's the 7? Who's the 7? I'll keep talking until you...
The constant K.
Yes, you're like the constant K. Shut up, Dr. Warren, shut up. Who's the g of x? Who's the g of x? The function. Who's the g of x?
X to the 4th.
There we go, x to the 4th. Harrison's like, make it stop, make it stop. Can I pull the 7? Can I pull the 7 out of the derivative? Does that flashcard not say I can pull the 7 out of the derivative? Julia! Can I pull the 7 out of the derivative?
No.
Julia? Yes, you can, Julia, you can. So, Julia, so you have it here, we can pull it out. What's the derivative of x to the 4th, boys and girls? What's the derivative of x to the 4th? You said you could do it. What's the derivative of x to the 4th?
4x to the 3rd.
4x to the 3rd, so this would be like 7 times 4x to the 3rd. What is 7 times 4?
28.
28. So this would be 28. X to the 3rd, and I can't do this anymore. Okay. Now, let's see. You're like, Dr. Warren, oh God, thank you, that stopped. So look, we just pulled the 7 out, and this is a lot easier than trying to attack this with the limit definition. Would you agree or not? If you had to show like the derivative of this function at 3, and it's even better, you're getting all the derivatives all at once. You're getting all of the derivatives of 7x to the 4th. At 3, 12, any number you want, you get the derivative there. Okay. I'm going to just show you though. I just want to show you, it's kind of sloppy. It's a little bit dirty, but it works. If you just took the 4 and multiplied it times the 7, what number would you get? If you just took the 4, the little exponent, and multiplied it times that coefficient, what number would you get? I know this is hard. If you took 4 and multiplied it times 7, what number would you get? 28. Okay? And then if you subtract 1 from 4, what do you get?
3.
3. So this is kind of a little bit dirty. I mean, this is the correct way of attacking it. But in the future, you can just go, oh, well, 4 times 7 is 28. And 4 minus 1 is 3. And find the derivative. So like, for example, let's just jump it up here. Suppose you had this. You'll never have anything that big. But suppose you want to take the derivative. Suppose you want to take the derivative of 5 times x to the 100. What do you think the derivative would be? Take a guess. Go take a shoot at it. Write it down. What do you think if you were asked to find the derivative of 5 times x to the 100? What do you think that would be? Write it down. Take a guess. What do you think that would be? Okay, now hands on the space bar. Get your hands on the space bar. What do you have as an answer? Everyone, all together. What do you got?
5.
500x.
500x to the 99. 500x to 99. It's just like taking the 100 and multiplying times a 5 and subtracting 1, and you get the x to the 99. Now here's the thing. One time I was showing this in class. to a student, and they were looking at it and they were like, I don't get it, Dr. Warren. And I'm like, okay. Well, I mean, I understand we're using the constant multiplier rule, and that came from product rule, and we're using the power rule there, you know, and then I was like, what is it you're not getting? And she goes, well, I don't understand the 7 times the 4. And I'm like, well, I know, we're taking the little exponent and multiplying times the 4. It's stupid, but it works. And then she's like, well, I'm not getting that. And I'm like, I'm sorry? You know what? And she goes, well, I don't get what's the 7 and the 4. And I'm like, what aren't you getting? She's like, why is 7 times 4 28? And it was like at that point in time, I was like, oh, okay, this is calculus. And I was like, well, what's 7 times 3? And they're like, 21. And then I'm like, well, what's 7 more than 21? And they're like, 25? And I was like, okay. She got a B. She got a B in the class in the end. She got a B in the class in the end. She just didn't know her multiplication facts. She never learned her multiplication facts. Brilliant girl, just never learned her multiplication facts. Let's test yours. This is one of the hardest ones. We're finishing with this. This was one of the hardest ones for you guys when you were learning it. You just couldn't remember this one. What's the derivative of 8x to the 7? What's the derivative of 8x to the 7? And what do you have? What do you got? 56x to the 6. How many people think they can now take derivatives of at least simple power functions, Now what we haven't done is we haven't hit Lindsay's question that she really gave us at the beginning. We don't have that negative 2x cubed plus 3x. We can't do that yet with what we've done. We can do the negative 3x cubed, yes. We can do the 2x, yes. But what's connecting those? Plus, we haven't talked about the derivative of a function plus a function. We got a function times a function, but you don't have a function plus a function. Z-dares. I will see you live in here with me on Monday. Our quest is Friday, all together. I'll send out an email. Okay, you guys are great. You play along with Dr. Warren really well. I know it's insane. Okay, I will see you. Have a safe, wonderful weekend. It's going to be beautiful. If you can get out and see some of the leaves, they should be changing up on Skyline Drive. Okay, so you should get out there and just embrace the fall. Okay, let's enjoy fall 2020. Okay, I will see you guys.
Thank you.
Thank you.
See you, Dr. Warren. Thank you.
Thank you.
See you guys.
Dr. Warren,
Yes.
what would be the format of the quest again?
It's just going to be you're just going to get a sheet of paper. It'll be like a page and a half, handwritten.
Handwritten, okay.
Yeah, no more WebAssign. No more WebAssign.
Class, would we just have to do that PDF thing again?
One more time, Alexandra.
If we're not able to go to class, do we have to do the PDF thing, or how does that work?
So it'll always quest on Fridays. And so the room's big enough to have everybody in there. If somebody's in quarantine, if they're in quarantine and they're feeling okay enough to take the quest. Last thing I want is anybody who's sick taking
Yeah.
a quest. But if they're feeling well enough, they would probably do the PDF. They would just download the PDF during class time and submit photos of their answers during class time.
Okay, and then also one more question. Are we gonna be able to use our notes or like a calculator, or is it just nothing?
You're allowed to use this. This is the most
Okay, so we
important
have
thing.
to memorize all the.
Oh yeah. So that, yeah, no, I mean, I would, and you know, in the end, it makes it so much easier because my students, they're constantly flipping through, trying to find stuff, or they're going through stuff. And if I give you a calculator, I've got to put all these application problems on that require all the use of a calculator, and then units and all that. It's just so much easier for the students when we just have our brain and a pencil.
Yeah. Thank you.
All right, have a good weekend.
You too.
And then I just have one more question about the homework. Would you have time real quick to just
Sure,
help me
Lindsay,
get past the
sure.
Thank you so much. So the problem is, once again, just to find the slope and equation of the tangent line to the graph of the function f at the specified point.
Yep,
But it's the f of x equals negative 5 over 2 x squared.
negative 5. What? Negative 5 over 2.
X squared.
Is the x squared in the bottom, or is it in the beside it?
It's beside it.
Okay.
Plus 4x plus 4.
And you're trying to find the slope at what point?
Negative 1, negative 5 over 2.
So you would start it the exact same way, where you would say tangent line, we ring a bell, you would write down a flashcard.
Correct.
Can you identify who C would be?
C would be negative 1.
So let's just write it down, the flashcard with that in the location for C. So we'd have y minus f of negative 1 equals f prime of negative 1 times x minus negative 1, and we'll just save ourselves some time and put a plus 1 there. Now to find f of negative 1, we can just put a negative 1 into our original function. Wherever we see the x, we put a negative 1, but they've already done that work for us. They've already told us what that is. So let's put that in there. I'd have y minus negative 5 halves, but that'd be y plus 5 halves. So now the only thing we have to do, and I say that almost jokingly, the only thing we have to do is find the derivative, the slope of the tangent line. After Monday, Lindsay, this will be so much easier. After Monday, it'll be so much easier. Like, if I look at that, with what we did today, you could take the derivative of this by just taking the 2 and subtracting 1.
Right.
The derivative of 4 is 0. This will take a little bit of time, but we could also take the derivative of this. But we haven't worked on taking the derivative across pluses, and that's what we're going to invest Monday into.
Okay.
So right now, your only option is to use the limit definition. Your only option is to use the limit definition of derivative. So I'll start us off, and then I'm going to let you have at it for homework. So I have f prime of negative 1. And then this is typically, right, I almost like to be Pavlov. I just figure if I keep saying it enough, and this is where I go la 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 la, and I'm hoping that people go, oh, that's limit. That now means limit. The limit as x approaches c, and we're like, oh, that's negative 1. I put my Gary Dreibelbis in, x minus c, and that's x minus negative 1, or just x plus 1.
So I got there pretty okay. Like up to
Okay.
there, fantastic. f of x plus f of c in the numerator, I was having a little trouble factoring it.
Okay, it's minus f of c. It's f of x minus f of c. I don't know if that might be.
Maybe that was my problem.
So Lindsay, it sounds like you got it down cold. It just
Yeah.
sounds like, yeah, it's f of x minus f of c. And so if this sign ain't right, it's not gonna factor. If this sign ain't right, it's not gonna factor.
Yeah.
So I mean, part of the problem too also is they've got negatives flying all over this problem. Negatives are everywhere in this problem. So this would be like the limit as x approaches -1. My Gary Greibel this ends up being a minus f of c, which is minus 5/2. Then you're going to put this function in. That would replace those guys. This minus is that minus. This minus is that minus, and this is the f of c. This is the f of c.
Okay.
Now you take your function here, and you put that in for that guy right there.
So now that I'm looking at my notes, that's actually what I did. Because obviously the minus negative 5/2 is just plus 5/2.
Good.
I actually did do that, but then once I got to adding the 4 and the 5/2, I got 13/2.
Let me just get this down here. So I've got this. I'm going to do it plus 5/2. Then we got the minus 5/2 x squared plus 4x plus 4. Good. You added these together and you got a 13/2.
I got 13/2.
Okay, so let me write that down. Plus 13/2. Now again, because I took away your calculator on a quest, I probably wouldn't put so many fractions in here.
Yeah.
Okay, now somebody's gonna have to deal with Gary Dreibel. So what does one of the factors up here have to be?
X plus 1.
So that's huge, a huge help. Now I know there's gonna be fractions and we don't like fractions. But as long as we don't panic, we're gonna be okay. As long as we don't panic, we're gonna be okay. I've got a 13/2 that you got me. You got me this 13/2. It's a plus 13/2. So I know this term has to be that plus 13/2, because when you multiply it back out, this times this has to be that.
Right.
Now, what does this term have to be? Given that that term is minus 5/2 x squared. If this is x, what does this term have to be if this is going to be a negative 5/2 x squared when you multiply that out?
Minus 5/2x.
Very good, perfect. And now you're like, Dr. Warren, you're lying to me. I don't trust the middle terms are gonna work. I don't trust the middle. And then we could just check. Okay, if I do my inners, I would get 13/2 x. If I do my outers, I'm gonna get a minus 5/2 x. The inners give me 13/2x. The outers gives me a minus 5/2x. Now you wouldn't need to do this, but 13/2 take away 5/2